Yeah, this is a tutorial on type classes. So the first thing we have to do is to determine why we need the type classes in the first place. So this is a small program, okay? It takes a number, an integer, and takes another integer, and we've created a small function over here. So this is an inline function. It takes one integer, another integer, and returns if the first integer it returns true if the first integer is greater than the next. Otherwise, it returns false. Okay. So we say that C is true or false depending upon whether the first integer that we enter is greater than the next, and it's false otherwise, and we just print that. So we print A is greater than B is equal to true or false. Okay, so I have already compiled it, and let's look at the result. So this is called type C, okay, type class. If you put the first integer as 2 and the next integer as 6, then 2 is greater than 6 is false. So that's good enough. Now let's say we wanted to see if 3, the first was greater than 4.5. Now we have a problem. You see, we cannot compare using this function an integer with a floating point object. It cannot. It wants, what it does is it wants this thing over here to be an integer, and it doesn't have a function. So you might think that, okay, well, we just want to create a function that takes a floating point value over here, and it returns a bool. So you'd be able to do that. Well, not really. So let's compile this. Typeclasse, and you see that it's going to have an error. The reason is because this is defined twice. You cannot create the same function twice. So how do we solve this problem? So this is where type classes come in. Okay, and we are going to solve this problem using a type class. So how do we handle this situation? There really are two ways in which to do it. The first thing is to see if there is an existing type class, and if there is, just go ahead and use it. And if there isn't, then just create a new type class. Okay, so we are going to solve the problem by both ways. The first thing we are going to do is to use a type class that already exists. Okay, and the next thing we are going to do is to just create a new type class, and it's going to be a good review of how to do that. So here are some of the more common type classes, and we know that we have to use the ordering type class. This is what defines whether something is greater than something else. So so this is the type class that we have to use. Now, how do we figure out what type classes do we have to use, and if there is already a type class that exists that we can definitely use. So for that, we have to go back to our function and take a look at it. So yeah, the question becomes, how do we figure out what type of type class we are going to use? Okay, so how do we figure that out? So the way to do it is to go back into the function. So this is the same program. I've introduced a couple new variables over here, and I've explicitly typecasted the inputs. Okay, so it's a little easier to see. So both the inputs are integers, and we are going to use this function that we just created to see if one integer is greater than the other. So in the same program, we see that the only function that we're using is the greater than sign. So what is what we would generally do under under this situation is that we would want to take a look at the greater than sign and see what it expects. Does it expect two integers, or does it expect two floating point values, or does it expect to an integer and a floating point value, and so on and so forth. So that's something that we have to figure out. And the way you do that is to go into GHCI and take a look at the type of the greater than operator. And as you can see, the greater than operator takes two values of the same type that are of the type class ORD, okay, ordering. So this is what we want the type class to be. So from here we know we have to use the ordering type class for the greater than sign to work properly. So we go back over here, and just like over here, we define, we change the way in which this operator is typecasted into a, that's the qualifier, a, and bool. By the way, you can put anything over here. You can put ABCD, and ABCD over here, and that should just do it. Okay, so let's see if we can compile this. And there is absolutely no reason why we should not be able to do that. So we go and say GHC typeclasse, and it does do typeclassing. It does compile, so we can do typeclasse and see it working. There's your 2, there's your 3, and it works. Okay, now if we go ahead and want to get a 2.3, then you may immediately get an error, because you can it expects over here an integer. Okay, so let's go ahead. Now we don't need an integer over here. We can put a floating point value. So we can ask the integer to input a floating point value, and then we change these typecasts to floats as well. Okay, and when you do that, things become a little better. Okay, so you go ahead and check out the program. You say 2.3 and 1.2, and it works okay. You say 2 and 1.2, and it works fine as well. See, here's a problem though. When we put 2 in over here, we are putting in a float. So can we go ahead and do this? Can we say the first thing is an integer and the second thing is a floating point value? Because, well, we should be able to compare 2 with 1.2. That should not be a problem. Okay, so how do we do that? We just go ahead and say this is an integer, and the next value is going to be a floating point value. So if that happens, then this should work as well. And we go ahead and try to compile it, and we'll see that there is an error. Okay, why do we have this error? We have this error because the greater than sign over here expects two inputs of the same type. Okay, if you give a floating point value over here and a floating point value over here, then you're going to be good. If you have a double over here and a double over here as well, you are going to be good. Okay, we can go ahead and compile it, and as long as both values are of the same type, it's going to be perfectly okay. But you will not be able to compare um, an integer 2 to a floating point 2.1. Just to make sure that that is the case, we can check over here. We can say 2 is an integer, and we want to see if it's greater than 1, which is also an integer, and the answer is going to be true. But if we go ahead and make one of them a floating point value, so we are comparing 2, which is an integer, with 1, which happens to be a floating point value, then this is not going to work. Okay, so the greater than sign is not going to be able to compare an integer with a floating point value. Okay, but really this is a very arbitrary way of doing things. Okay, we should be able to compare an integer 2 with a floating point 1.2 or 1, for example. So how do we overcome this? Clearly, doing this is going to help to a certain extent, but it's not going to be it's not ideal. We need something better than this. Okay, so how do we go ahead and solve this problem? We can go ahead and kind of trick it. Okay, so this is a type int, alright, and then over here when we are converting, we can do use a function from integral, and just so you know, if 2 is type int and we say from it helps if I type correctly. Okay, then the type of from integral is a number. Okay, so it's something that you can use for a lot of different things. So over here you can go ahead. So by the way, from integral does not give you a floating point value. From integral gives you a number. Okay, so you can go ahead and type class the whole thing as a float. Okay, this whole thing, you see, is of type float. So now what you can go do is go ahead and compare this to one which is of type float. Okay, now when you do you can do that. So for example, you can go ahead and say, okay, this is from integral, and then I am going to convert that into type class number, and then I'm going to type class that to be double. Okay, so when we are comparing A1 and B1 over here, we are really comparing two doubles, and we have no problem. Okay, let's just compile it and make sure that that's the case. And it works. Let us just okay, so we put a number which is an integer, so we put 1 and 2.1, and as you can see, it gets converted to something else. So if we over here go ahead and say show A instead of show A and B, okay, then we can actually look at the types that we put in. So let's compile this again, and I'm going to put in 2 over here and 1.2 over here, and as you can see over here now we are comparing an integer to a floating point value. Okay, and it's able to do it properly, but see over here we really cheated. Okay, this we are not comparing an integer with a floating point value. We are comparing double with a double. Okay, and I typeclassed the first number, which happened to be an integer, into a double. Okay, I did that and I made it equal to the other one. So we are comparing two different values, not the values that we input. And this is cheating. Okay, so we need to be able to do better than this. So this is an ideal situation where we can go ahead and create our new type class. So let's do that. Yeah. So how do we go ahead and do this? How do we go ahead and create this function that can take anything we give it and tell us whether the one thing is greater than the other? Okay, how can we create a function that can compare an int with a float? So that's the basic reason why we are doing this. So for that we create our own type class. Okay, how do we do that? We declare a type class. That's how we declare a type class. We have to give it a name. So let's give it a name called compare, and that's just for naming purposes. Remember that anything that you name should begin with a capital letter, so that's standard in Haskell. And then you say it's gonna have two different variables that we'll care about, A and B. Okay, and you have to define functions, okay, which is going to be part of this type class. So one of the functions that you can say is well, in our case we only have this one function, and then over here you have to specifically type show the type of this function. So this will take something of type A and something of type B and will return a bool. Okay, this is kind of in line with that so if you went ahead and looked at the type for the greater than sign, it was something that took a and returned a bool. But now what we're saying is it's gonna not take two types of two things of the same type class, but it's gonna take two different types. Okay, it's gonna take two different types and then it's gonna return a bool. So that's where we differentiate from our old implementation of the greater than sign. So now we've created this class, okay, and we have to create and specify that this function is part of this class, type class rather. Now what we have to do is we have to create specific instances of this class. Okay, so we can say instance compare. So first we'll go ahead and okay, just comment this section out. Okay, so and then we'll go ahead and say okay, an instance of compare will take an int and an int. Okay, where we define this function. Now if a and b are ints, we'll just define the function over here. We'll say this equals a greater than b. Okay, now that's a specific instance of this type class. We don't have to limit ourselves to this one instance. Now we can go ahead and create as many instances as we want. So for example, if we want to compare a float and an int, then we just go ahead and put from integral over here, okay, and if we have an int and a float, we'll put over here. And so we can go ahead and compare a host of other functions. For example, we can say double over here and double over here, and so we can compare ints with doubles, we can compare ints with floats, we can compare ints with ints, we should be able to compare ints with floats, floats with floats. So let's just do that, and doubles with doubles. And floats with floats. And we keep adding. Okay, I'll not finish everything over here. You can do that in your own time, but this is what you do. Okay, yeah, so we have to provide A and B over here. My bad. This is how you define a function. And not over here. Okay, that's a type signature. Yeah, and we also have to put in this thing over here. Okay, now when we say, okay, we can put 2 and 3. So we have to now go ahead and change this. So we can, at this point, compare a double and a double. Okay, we have an instance for that. So if we okay, we have to compile it again. Okay. So now we are comparing two doubles. We are comparing 2 and 3. Okay. Now we'll compare two integers. See, now okay, 3 and 2, and then we'll compare an integer with a double. We have a provision for that somewhere. Integer and a double. Okay, we will compile that, and the first thing is an integer, and the second thing is a double, and that works. So that's basically what we are getting at. We want to create a class, and we want to be able to create we want to be able to compare anything we want. Okay, so that's how you do it. There are times when the available functions are not going to be good enough, and you have to create your own type class, and this is how you do it. Okay, let's finish this off with creating a new type. Okay, data type, and going ahead and using this class compare to compare that new data type, because obviously if it's a new data type, the greater than sign, the available greater than sign, won't be able to compare um, your new data type right off the bat. So we'll see how we can use um, this new greater than sign to compare that data type as well. Okay, okay, let's do it then. Okay, so we go ahead and create a new data type now. Okay, so and this new data type is not going to be int double. It's not going to be a number, and it's still something that needs to be compared. Okay, so let's create a data type with the keyword data, and we'll call it RPS for rock paper scissors, and we'll say it is either going to be a rock. These are the data values in the data type. Okay, it's either going to be a rock or a paper, or it's going to be scissors. Okay, so that's the data type. Let's go ahead and also derive deriving, deriving will derive the read and the show functions. Okay, this is just a shortcut so that we'd be able to read from the keyboard and print it using the show function. Okay, that's just what it's doing. So what we are going to do is we are going to create an instance of compare, and we are going to compare an RPS value with another RPS value. Okay, where and we have this only one function in compare, so we only have to do that, and we say A and B. Well, actually, you know what, I think copied, yeah, there you go. So this function, this is how it's defined. You have rock and scissors. Rock is greater than scissors. Scissors, pair of scissors is greater than paper, and paper is bigger than rock because apparently it can fold around rock, and everything else is false. So in life, if A is or let's say in mathematics, if A is greater than B and B is greater than C, then A is greater than C. Commutative, I think that's what it's called. In rock, paper, scissors, not really. You can do whatever you want. So we can go ahead and get an RPS, and another RPS over here, and we will say A is an RPS value and B is an RPS value, and we're going to compare these two. Okay, and we see if we can compare RPS values. Okay, so we do a compile of, yeah, we just compile the type class. I've written compare somewhere over here. Compare. That should do it. Okay, and let's see if this works. Okay, we say rock should be greater than paper, and well, actually paper is greater than rock, so I'm wrong. So well, there you go. You can create a new type class, and you can even create a new data type, and you can have a compare sign that compares not only ints with floats and doubles with ins, but also rocks with papers, and so on and so forth. So that's your type class tutorial. Take care.